So you have this whole giant formula page and you have a piece of color paper. Now, hopefully you have holes punched in each side. I want you to take the colored paper. I want you to fold the holes over just a little bit, like that. Thank you. Now, why would I give you a piece of, or a giant formula page, and then give you another piece to cover it up with? Yes, because you panic. That's why. This is a lot of formulas, a lot of things, right? So, can you tell that there are 4 sections on this page? So I want you to carefully cut so that you can only see one section at a time, and only cut up to the fold. See, so if I open this section, I can only see that top section. I can't see any of the other stuff. I can only see that part. Same thing here with the second section. Same thing with third and fourth section. Cut in between them so you can only see one section at a time. Only cut to the fold. So we should be able to uncover and just look at parts and pieces at a time, yes? But if we don't know what's behind there, that's going to get really old really quick. We might as well just sit the whole thing up so I can see it all, right? Okay, well, I don't want that. I want to know what's inside without having to move the cover, yes? So let's label each of these sections. Okay, this top section, it has a vertex at 0, 0. Let me zoom in just a little bit more. Vertex is 0, 0. And this particular section talks about a vertical axis of symmetry. Vertical axis of symmetry. Guys, if it has a vertical axis of symmetry, what does it look like? It looks like these that we talked about yesterday, right? The foldable that we made yesterday only talked about vertical axis of symmetry, right? Only vertical. So this one either opens up or down, right? Now the second section has a vertex also at 0, 0, but it has a horizontal axis of symmetry. Guys, which way does a parabola open up if it has a horizontal axis of symmetry? Left or right? Okay, so left or right? This has a vertex, this section, this third section has a vertex at HK, and it has a vertical axis of symmetry. Which way does the vertical axis of symmetry open? Up or down? Good. What do you think the last section is going to be? Use your context clues. So vertex at HK. Very good. Horizontal axis of symmetry. And horizontal axis of symmetry opens left or right, right? Now this way we can take pieces and parts at a time. We don't have to see the entire page. We can see little pieces and parts of what we need. Okay? Now, not that I want to frighten you, but I do want you to look real quick at the whole page. Okay? What on this page do you not already know? Don't you know already stuff about the origin? Don't you already know stuff about vertex at HK? Guys, there's only one part, well, I guess technically 3, but there's really only one part that you don't know, and that's the P. Okay? And if I teach you what the P is, then you'll know what the focus is and what the directrix is. Okay? So let's just look at this very top section. This is what we're familiar with. Okay? It's what we're familiar with. Notice what the equation is. Y equals 1 over 4p x squared. What equation are we used to seeing? Y equals a x squared, right? That's what you're used to seeing. So can you tell me something about a? Isn't a and 1 over 4p the same thing? So why would I teach you 2 ways? It depends on what you're given. Right? If you're given an a value, great, use a. But if you're given a p value, a is not going to help you. You need that p value, right? Okay? So here's the deal. 1 over 4p. What does that even mean? Well, here's a picture of the graph, okay? From the vertex to the focus. Notice that the vertex is 0, 0. We knew that because it says it's at the origin. But if the vertex is 0, 0 and the focus is at 0p, how far away is the focus from the vertex? P, right? It's p distance away, right? Well, if the vertex is 0, 0 and the directrix is y equals negative p, how far away is the directrix from the vertex? Also p, right? We're talking about distance. So even though it's down, we still should say it's p, right? So the distance from the vertex to the focus and the distance from the vertex to the directrix is p. So anytime it starts talking about a focus or directrix, you know that p is going to be involved, and you know you want to use this equation as opposed to any of these equations that we talked about yesterday, right? Okay? So here's the deal. What the heck is a focus and what the heck is a directrix? Have you ever heard of those words before? Probably not in relation to a parabola, right? Okay? I'll tell you this. The focus and the directrix is actually what creates the shape of the parabola. Any point that I choose on the parabola, if I measure the distance from the focus, it will be the same distance as the distance from that point to the directrix. I could choose that point. I could choose this point up here. As long as I come down perpendicular to the directrix and go directly to the focus, do you see how those distances are the same? Do you see how these distances are the same? Okay? So there's certain situations where we'll want to use equations like this from yesterday, and there's certain situations that we'll want to use this depending on what we're given. Does that make sense? Okay, so let's do a couple of examples so you can see that this is not really anything to be scared about. Okay? I'm going to move this over to the side so you can see my notes. Okay? Or my examples. Sorry. Let's start with this. X equals 1 over 24 y squared. What I want you to be able to tell me is which direction it opens, where the vertex is, where the focus is, where the directrix is, and where the axis of symmetry is. You think you can tell me all that stuff? How does this start? Literally, how does it start? X equals, right? Now, are we used to writing things x equals? How do we normally write them? We normally write y equals, don't we? Well, if we're writing something that we don't normally write, does it make sense that's a parabola that we don't normally study? So this is going to have a horizontal axis of symmetry, so I want to look at this stuff. Okay? Let's see if I can go back and forth from these things. So I need this equation to say 1 over 4p. Well, it already says 1 over 24. Is that something I could easily convert into 1 over 4 times something? What is that something? 6, right? Because 4 times 6 is 24. What does that mean that P is? P is 6. Okay? Well, did we already decide which direction this opens? Well, according to this, it either opens left or right. How do we tell the difference if it's opening left or right? Yeah, is this negative? No, so which direction does it open? It opens to the right. Where's the vertex? It's at 0, 0, right? It's at 0, 0. Wait, how do I know that it's not somewhere else? Besides the fact that we're using this one? How do I know it's not at HK? What does HK look like? Oh, there's some parentheses involved and a number being added or subtracted after that. Do we have that here in this equation? We do not, so we know our vertex is at 0, 0. Okay, where's the focus? P, 0. Well, what did we say P was? 6, so 6, 0. What's the directrix? X equals negative P, and we said P was 6, so negative 6. And where's the axis of symmetry? Y equals 0. Yes? Questions? Okay. What about this one? Y equals negative 1/12 x plus 1 squared plus 3. Wait, can we go back to this real quick? Just to make sure you understand. The vertex is here. The focus is here. And the directrix is here. You said it opened right. Does that make sense in this situation? Where is the focus always in relation to the parabola? It's inside. It's like the parabola is going to eat the focus, like as a snack. Okay? The directrix is on the other side. It's away from the focus on the other side from it. But the focus is always on the inside. You okay with that? Okay. All right, look at this one. I need which way it opens. I need the vertex. I need the focus. I need the directrix. Whoops. Not directress. I don't know what that means. An axis of symmetry. Try to spell directrix right, but if you don't, I'll forgive you. All right, what do we know? How does it start? If it's y equals, what does that mean? It's y equals, right? Y equals is here. Now, why did I open this one and not this one up here? Yeah, there's stuff, right? There's stuff being added inside parentheses. There's stuff being added at the end. So I know that my vertex is not at the origin this time, don't I? Okay. So if it's y equals, I know it either opens up or down. Which direction does this open? Why do you think it opens down? Because it's negative, right? So this opens down. Where is the vertex? HK. So where is the vertex? Negative 1, 3. Very good. Okay. So the vertex is at negative 1, 3. How are we going to figure out the focus? What do I need to change this to? 1 over 4 times what? 3, which means P is 3, right? 4P. So where's my focus? It's 3 away from my vertex, right? That's my vertex. And I know it opens down, so my vertex is down. So that is my focus, isn't it? So -1, 0. Where's my directrix? If here's my vertex and my focus is down, where's my directrix? Up. How many? 3. That's right there, right? Which axis is this crossing? It's crossing the y-axis. Where is it crossing? At 6. Where's my axis of symmetry? Yeah, it's going right through the vertex and right through the focus here, and that would be the equation x equals -1. Okay? Now, guys, I didn't refer to this at all, did I? I just used some logic. Why wouldn't I refer to this at all? First of all, we tried to use logic, right? Could I use this if I wanted to? Yeah, I know all this stuff. HK, I even labeled it. HK. P, I even labeled P. If we do this, all this stuff again with this, we're going to get exactly the same answer, aren't we? Okay? Any questions on this so far? Okay, so now what we need to be able to do is we need to go the other way. Okay, we actually need to write some equations. Okay, I need to be able to say to you, the focus is at 0, 3, and the directrix is at y equals -3. And I need you to be able to tell me the equation. Okay? So if my focus is at 0, 3, and my directrix crosses the y-axis and -3, what do you know? Which way does it? Oh no. Can you tell I'm having a rough day? This is totally wrong, isn't it? How do we graph the point 0, 3? 0 left and right. Okay, let's just ignore the pink for now. Can we do that? You can tease me about this later, just not today. 0, 3. 1, 2, 3 is right there. Oh my gosh, I should get fired. 1, 2, 3. Crosses the y-axis at -3. What do you know about this? Parabola. It opens which direction? It opens up, right? How did I know the vertex was right here? The vertex should be where? Halfway in between, shouldn't it? 1, 2, 3, 4, 5, 6. So it should be at 3. So there's my vertex. So my vertex is at the origin. I know it opens up. So let's use this page. Y equals 1 over 4p x squared. Y equals 1 over 4p x squared. What do I have left to know to be able to finish the equation? I got to know p, don't I? How do I find p? Yeah, I look with my eyes, right? Where's my vertex? Where's my focus? Count. 1, 2, 3. Where's my vertex? Where's my directrix? Count. 1, 2, 3. What's p? P is 3. Finish the equation. 1 over 12x squared. Done. I'd say let's just ignore this, but I'm literally recording it, so it's going to be on the interweb forever and ever. So, we good? Another? What if I say the vertex is at 0, 0, and the directrix is at x equals 5? So the vertex is at 0, 0. The directrix crosses the x-axis at 5. For the record, I am confident that's right. I slowed down in my thinking a little bit, so I make sure I'm not going too fast. Which way does this open? What? Left. How do you know it opens left? The directrix is over here. I know my parabola opens away from my directrix, right? Now, last period they were concerned about the shape that I'm drawing. How do I know that's the right shape? I don't. I'm not worried about that right now. I'm only drawing it that way so I can tell myself it's opening to the left. Does that make sense? There's a time, and there was already a time, in fact, that we got a table and plotted exact points and got the shape of our quadratic, right? Not worried about that right now. We're worried about trying to write an equation. Are you okay with that? So if this is opening left, what's my equation? How does it start? X equals, right? X equals 1 over 4p y squared. Now, I chose that one in particular because the vertex is at 0, 0 already, right? It already told me that. Okay, so all I have left to figure out is what? P. What's P? 5, and how did I figure that out? I literally counted, right? So my equation is x equals, ooh, I don't want to mess up. I don't want to mess up. So that's not wrong, so I'm going to go ahead and write it. What am I missing? Which way does this open? Left. If it opens left, you're right. I have to have a negative right there, right? Probably should have written it right there as well. Okay? How are you feeling about this? Okay so far? Good. So what if I tell you that it opens left? And I tell you it has a vertex at -1, -5, and that it's 7 units from its focus. Oh, you can't even see any of that, sorry. It opens to the left with the vertex at -1, -5, and it's 7 units from its focus. Okay, well, you know me being a visual learner, I want to see what that looks like, right? So -1, 1, 2, 3, -1, -5 is the vertex, and it opens left, and the focus is 7 units away. So where's my focus? What direction? Left. 1, 2, 3, 4, 5, 6. Now, do I care where that is? I could count it and figure out where it is, but do I care? I do not, because what I have already is HK, and what else do I have? I have P, don't I? And isn't that all I need? Okay. So this time I'm using one of the bottom two, right? And I know it opens to the left, so I'm using the very bottom one, don't I? So I've got x equals 1 over 4p y minus k squared, whoops, plus h. Guys, don't I know all this stuff already? X equals 1 over 4 times 7, 28, y minus k, so y plus 5 squared, plus h. We're not there yet. But yes, absolutely. Okay, so what she just said was, shouldn't it be a negative at the beginning? Why would it be a negative at the beginning? Because it opens left. So yes, we have to make sure. Good job. We have to make sure we have our negative there. Okay, I just want to make sure to fill in all this other stuff first. And absolutely, that's what we're going to talk about next. But good job. Okay, and we're done. That's it. What about this one? Passes through 13, 8 with the vertex at 3, 2. It passes through that point, and my vertex is here. Is this P? It's not, is it? This is just a random point on the parabola. So we don't have a P in this problem. It doesn't tell us a P in this problem. So if there's no P, what should I be looking at? I should be looking at this, shouldn't I? From yesterday, remember? Which one of these should I be using? Well, what do I know? I know a vertex, so maybe this one, vertex form. So this time, what I know is HK, and what's this? Isn't that X and Y? So if I'm looking at vertex form, what do I not know? I don't know A. That's what I got to find, right? Okay. Now, I want to stop some confusion right here, okay? Because can you see how this is my vertex? It can open up. Can you use your imagination and imagine that? But if this is my vertex, do you see how it could open this way as well? Let's just worry about functional parabolas if you have a choice. So it's y equals. Are you okay with that? Okay. So let's use vertex form for this and fill in what we know. Okay. If we're filling in what we know, we have y, which is 8, equals a, which is what I don't know, which I'm trying to find, x, which is 13, minus h, which is 3, squared, and then plus k, so plus 2. Okay, so far? Does anyone know what 13 minus 3 is? 10. Excellent. What's 10 squared? So 8 equals 100a plus 2. Can you solve this equation? Yeah, you have been since like 7th grade, right? So this is not something I need to worry about. 8 minus 2 is 6. 6 equals 100a. How do I solve for a? Divide by 100. A equals. Could I get a decimal here if I wanted? Could I simplify this to be 3 over 50 if I wanted? Yeah, both of them are correct, aren't they? Now I've got to write my equation now that I know a. When I go to write my equation now that I know a, do I substitute in x and y? No. Do I substitute in h and k? Yes. Okay. So y equals a, which is 3 over 50, x minus h squared plus k. Yes? One more? Okay. Intercepts of negative 16 and negative 2 passes through negative 18 and 72. Intercepts of negative 16 and negative 2 passes through the point negative 18 and 72. So what do I know? Well, I know an x and y for sure, right? I don't know an h and a k because it didn't tell me a vertex, did it? But what did it tell me? Intercepts. Does that ring a bell from yesterday? Intercept form. So what do I know? P and Q, right? Now the only thing I don't like about stuff like this is that this P and this P is not the same. Those are different values. Do you understand that? Okay, good. So if I'm using this, what don't I know? A. So let's find A. Okay? So Y, which is 72, equals A, which is what I don't know. X is negative 18 minus P, so minus negative 16. So plus 16. And X, which is again negative 18, minus negative 2. So again, plus 2, right? Now we just need to simplify this, don't we? 72 equals A times, what's negative 18 plus 16? Negative 2. And what's negative 18 plus 2? Negative 16. So 72 equals 32A. And to solve for A, divide by 32. A equals, just to make sure you know it's okay, I'm going to go to a decimal on this one. Okay? So what's my equation then? Y equals A, which is 2.25, times X minus P times X minus Q. So you're going to need both of these today, aren't you? You got to look and see what you're given to see which one of these to use. Yes? Okay. And what's the last thing you need to do on this one? Put your name. Yeah, put your name on the back, please.